Hey there! My name is Chroma, and welcome to part 1 of Making an Abstract Adventure. Starting off the first real episode of this series, I have already made quite a bit of progress towards making a basic character controller, as well as a sample environment sort of thing set up. So let's hop over into play mode so I can show you what we've got so far. And then we'll go over into Unity and Visual Studio so I can show how it's running behind the scenes. So starting this off, we can move our sphere character here left and right. We can jump using the spacebar. Holding it down, we get a higher jump. Just tapping it, we get a shorter jump, and all of that. We can also double jump, and that's all working as we want it to. We also have the camera following behind the player, sort of slightly lagging behind just a bit. And then we can also fall under gravity and all of that. As well, when walking off an edge, we get a split second of being able to still jump before it's kind of disabled there and all of that. So now let's go and see how this is all working together. So first of all, our environment here is just a bunch of sprites of either white squares or white circles that are just tinted. That'll be replaced with better art as we go through development, I guess. So, and here in our environment empty game object, we have 3 other empty game objects for organization for our background, midground, and foreground. Foreground doesn't currently have anything under it, but the background has the sky, the midground has the floor. That'll mainly be used for parallax scrolling, of having the background and foreground elements sort of moving by at different speeds to give a better illusion of depth. Our floor layer also has, or our floor object is in the layer environment that I've created. That'll be used for ground detection and all of that. So next, onto our player here, who is named Cal because he's going to be a knight named Sir Cal. Haha. Alright, so we have Collider here, a rigid body that is mainly used just for the jumping and the falling. The moving left and right is done using just manipulating the transform, as we'll see when we look at the code for that. So now on the actual code that we scripted on our player, we have 4 scripts here: circle main, player move, player jump, and player double jump. As well, we have an empty game object as a child object of the of our player that has just a box collider on it, and our player ground check script. That this is just a small square underneath the player that when this is a collision with something that's on the environment layer, it'll say, yes, we're on the ground. So anyway, so most of these script names are self-explanatory as what they do. This one has to do with how the player moves. This one has to do with how they jump and fall under gravity. This one has to do with how the player double jumps. Then circle main is a script that kind of controls all of them. And then by doing it this way, we can, through other code, simply disable or re-enable this script, and it will disable all the movement of the player. And that'll be useful for if we want to activate like mini cutscenes in a level or something like that, where we temporarily want to not allow the player to move and that sort of stuff. So as opposed to getting references to all of these scripts, we just get a reference to this one, disable it, and all that. Now, next, we have this trigger test object that was just used for, actually I can just show that off in script really quick. All it does is when the player collides with it, it prints its name. That's just to test for later on when we collide with triggers for maybe checkpoints or at the end of the level or activating some sort of mini cutscene thing. That's all working successfully. Next, we have our camera that is set to orthographic because it's a 2D game. 10 as the size seemed to work just fine. And we have the background color set to black as kind of a void thing, but we do have this sky background because we will be eventually replacing that with actual imagery of some kind, like, I don't know, buildings, trees, whatever our environments look like in our levels. Then scripting-wise, we have this camera follow script that is set to, at the moment, follow the player, having this sort of height offset, but then there'll be another mode where it can be set to pan over to another object to show it off, and then it'll pan back to the player. That's how that's set up. And yeah, that covers all of our game objects in Unity. So now before we hop into our code, a few other objects we have in our project window is a physics material called frictionless that's applied to every object in the scene, or everything that has collision, just because we'll be dealing with the friction type of stuff in our code manually and not having Unity do it. So this is just a physics material, has friction set to 0 and bounciness set to 0, and all that. As well, speaking of physics, over in the project settings under physics 2D, gravity is set to -15, just giving it a slight increase so we fall a bit faster, or most objects in the scene fall a bit faster. We have our cal player and our camera set as prefabs. We only have, well, one actually used scene for this prototype here, are the sprites that I've mentioned. And now let's move on to the script. So we have our trigger test script here, and in a folder for organization called player, we have our other scripts here. So now let's head over into Visual Studios and show them off, how they're all working. I'll start with the circle main because it kind of has to do with how everything else is working. So it gets references to our player move, player jump, and player double jump scripts. Actually gets those references in the start function. And actually, while I'm at it, I can probably change that to the awake function. That'd probably work just a little bit better. And then in its update function, it calls a move script on the player move, the double jump script on the player double jump, and the jump script on the player jump. The reason why the double jump is called before the jump, we'll see when we get to those scripts. But for now, yeah. And then in fixed update, we have, we're calling the player fall script because that's something that's applying physics every frame. And usually that's just better to be done in fixed update. Although the normal jump, that's just applying double jump and double jump, that's applying just one frame of force. That's done in normal updates, again, as we'll see when we get there. But now let's move to the player move script to see how that's working. So we have 3 public variables here for the speed, the move smoothness, and the stop smoothness. As well, private boolean for whether or not we're facing the right or the left, and that'll be used for stuff later on. It's actually not used right now, but it will be eventually. So then we have a private vector3 for the move direction. So we calculate what way the player should be moving, and then multiply it by the speed, and all that to get it to actually move. And the move smoothness and stop smoothness basically have to do with having the player speed up to their max speed as opposed to just snapping to it. And having 2 different smoothness values for when they're speeding up and then slowing down to a stop. Then, getting a reference to the player ground check to test if we're grounded or not. Because it's not used yet, but eventually we might have slightly different speeds for when you're moving in the air and moving on the ground. So then in our start function, we get references to the player ground check and set that to a default value facing right. So when it's true, we're facing right. If it's false, we're facing left. Now onto this move script that is being called by the circle main every second, or every update frame. First we get if we're pressing the D key or if we're pressing the A key. If we're hitting the D key, we want to be moving right. So our move direction, we calculate what that's going to be, and it's going to slowly linear interpolate or lerp from its current value to transform.right, which is basically to the right. It's doing that by our smoothest value times time.delta time. A lot of these calculations here are multiplied by time.delta time, which will be useful for our game running at different frame rates and keeping things consistent in doing that. And as well, eventually when we deal with pausing, then all these things will pause successfully as opposed to needing to continue to calculate while we're paused, which is not what we want. So yeah, then if we're not pressing D or if we're pressing A, then we're moving to the left by just having a negative sign there. And if we're not pressing either of those, then we're slowly going towards a move direction of vector 3.0. Then with that calculated, then we add it to our transformed position, multiplying by the speed, multiplying by time.delta time. Next, let's go over to the jump script that kind of works hand in hand with the player ground check of whether or not we're on the ground. So we have 4 public variables here for the jump force, the low jump multiplier, which is how we fall quicker when we let go of the spacebar while we're jumping, fall multiplier, and a gravity multiplier. Then we have private references to the rigid body, the ground check, and the double jump. Then we get all 3 of those references in our start function. Next, in our fixed update, basically we're then applying a constant gravity force all the time. And the reason why we have this gravity multiplier as opposed to just increasing gravity over in the physics manager thing, even though we already did that a bit, is so that if we have other objects in the scene that are affected by gravity having a rigid body, we don't want to be massively increasing how much they're falling, but the player will be falling a bit faster, so that's why we just have that gravity multiplier on there. So yeah, then our jump script here, first we test if they're grounded, then if they hit space, and actually this should probably be a combined or statement, but I'll do that later. So if they're grounded and they hit space, then apply the jump force with transform.up times the jump force times 10, and then using force mode 2d.impulse, so it's more of an explosion force kind of thing. Then we set them to not be grounded anymore, and then once they've jumped, then we set it so that the double jump value is true. And this is why we have the double jump script run first, because otherwise, if we run the jump script and then set this to true, and then we jump, then it tests to see if we can double jump. That will also come back as true, so then we jump and double jump on the same frame. We don't want that, so that's why we do this. That's why I'm doing it in this order. Then our fall script is kind of the opposite. If we're not grounded, and then if the y component of our velocity is greater than 0 and we're not pressing space, then we apply the low jump multiplier, so we fall faster when we're not hitting space. Then we have this additional fall multiplier for if we're not in the air, and if the y component of the velocity is less than 0, then we apply more force to fall even faster. So yeah, and the reason we have the fall multiplier and a gravity multiplier is even while we're on the ground, we still kind of want to be applying a small bit of a gravity force so that right when we leave a platform to fall, we already have some downwards momentum as opposed to falling a lot slower right off the bat, and it just works better. But yeah, but this fall multiplier only is applied when we're falling and we're in the air. So yeah, next onto our player ground check, we have this fall delay, which is right when we leave a platform, having that like split fraction of a second of still being able to jump, which just tends to work better for platformers. So that's why we have that. Then we have a public variable that's hidden in the inspector that is whether we are grounded or not, and we've already seen that it's used by the player move and the player jump. So yeah, then we get a reference to the player double jump script, and then we get that reference over in start. Then having an on trigger stay function, which runs for every frame that we're in collision, but a trigger collision with another object. We test first if we're not already grounded, and the thing that we collided with, if its layer is 8, which means it has that environment layer that we saw on our floor, then we set is grounded to true, and then we set our ability to double jump to false, because we can't double jump when we're on the ground, because instead we should be normal jumping. So yeah. Then on trigger exit, when we leave a platform, then we test if we are grounded, and the thing that we just left has the layer of 8, then so down here we have a coroutine. We're going to stop that coroutine if it's currently running, and then start a new one, or start it again, which is this other function called wait to fall. And a coroutine is very similar to a normal function. It's basically we are able to have delays, so we can have time delays before a certain code runs, and that's exactly what we do here with our fall delay. Then if we're still grounded, then we set is grounded to false, and then setting our ability to double jump to true. So that's how that works. Then on our player double jump script, which is similar-ish to our normal jump, but slightly different. So we have a public variable for the double jump force, which works hand in hand with the normal jump. Then we have a public but hidden inspector boolean for whether or not we can double jump, and a private reference to our rigid body that we again get in our start function. Then the actual script of whether or not we can double jump or not. So we first see if we can double jump, and if we are pressing the space key. Most of these calculations as well, by the way, are on get key down, so only the frame that we press the space bar, not just by holding it down. other than in the jump script when we are testing if we are in the air, or if we want to do the low jump thing, that's just on get key. So yeah, for every frame that we're not pressing the space key, that's how that works. So anyway, over here, so if we do meet both of these conditions, then we set the rigid body's velocity to 0. So we kind of, if we're falling, we kind of stop that velocity. So we kind of have the same consistent jump. And then it's not necessarily just adding to the velocity. So we have that regulation in there. And then this is basically the same as the normal jump, just with the double jump force instead. And then we set the fact that we set can double jump to false, so we can't double jump again until we've hit the ground, and then it gets set to true. Next, on our camera follow, our last script to go through. So this, most of these public variables were explained, and you can see them in the inspector. Having these be like their own class basically means it allows us to have the fancy drop-down menu, so that's why that was done that way. And then having an enum is how we could have that choice between two options, and that can be changed through code on other objects when we get there. So it also has, a reference to the player. Player, reference to the player right here, and it gets that reference in the start function, and it also has a move position thing similar to the player move script. So now this happening in late update, just for it to work better with moving with the transform and the physics calculations and all that. So we test if the mode is to be following the player, and if it is, then this calculation is very similar to how we calculated the move position over, or the move direction over in the player move, which is that we're linear interpolating from its current position to the player's position, but the Y position also gets the added player height offset. So it's not exactly following the player, but slightly above them. And then this player smoothing value works the same as the smoothing over in the other player move script. If otherwise, if we're had to be following something else, then there is a look at target object, and it'll be following that instead, and it doesn't have the height offset in there. So, and then finally, it applies that move position there. Eventually, I think the next main thing I'd be working on is improving this camera system and doing a bit more fancy stuff with that camera following. But for now, this works just fine. So heading back into Unity, that does it for this development log. If you have ideas for anything that you want to see in this game, please suggest them in the comments below. Thank you all so much for watching, and I'll see you around.